Welcome to the Eduonics Cloud course. We will start our introduction to the cloud and to the course in general with a quick overview of cloud operating systems. Let's start by setting a context for what we think of as the cloud and also what we will come to understand as a cloud operating system. This is the Red Hat website. Red Hat are the makers of the operating system Red Hat Linux. The percentage of servers on the internet that are running on Red Hat's Linux operating system is rapidly approaching the leader in the server market, Microsoft Windows Server. Analysts predict that in the future, Red Hat Linux will become a serious competitor to Windows for the enterprise server space. So, if we look at the services that Red Hat offer, we can see, apart from their flagship operating system, they offer JBoss middleware. Then we have virtualization, cloud computing, and storage. Now, we will focus on cloud computing and virtualization in this course. But both cloud computing and virtualization draw very heavily on the operating system. Red Hat's new operating system, Red Hat Linux version 7, is designed specifically to offer virtualization and cloud computing platforms out of the box. Red Hat achieved much of its initial success by being one of the first companies to recognize the power and future of Linux, and they created their own version of Linux, and with this they were able to compete with Microsoft in the hardware server space. So, with the explosion of the internet, when we needed to create applications, we had to run our applications in a physical server. The Windows Server operating system was expensive and limited. Using Linux, you could set up an Apache server with a PHP module and a MySQL backend, and this was extremely competitive with Windows technology stack, which consisted of the enterprise server and SQL server as a database. Running our LAMP stack on vanilla Linux was not a commercial proposition for big companies which needed the security and other services that a professional operating system would offer, and this is where Red Hat came in. By offering these services in Linux, they offered a professional product that, once combined with the LAMP stack, became a very serious competitor to Microsoft. With the release of Red Hat Linux version 7, with its virtualization and cloud architecture built into the operating system itself, Red Hat is now in a position to make a similar move into the virtualization market. So, just as Red Hat was able with Red Hat Linux, which is really just its own commercialization of the Linux kernel, Red Hat is now going to move into the virtualization space, where the big player is VMware. With the cloud architecture and VM virtualization built into its operating system, it's in an excellent place to steal market share from the big players. And if we move over now to the actual breakdown of the market share, you can see for virtualized servers, VMware has 64% of the market. So, it's in the same place Microsoft was with Enterprise Server at the start of the Internet. You can see Microsoft is only a small player, and Red Hat 2 is only a small player. With the release of Red Hat Linux version 7, we can strongly expect this percentage to increase. VMware is a company that is predominant in the virtualization marketplace, and so they offer the ability to create virtual machines, and Red Hat now is in the position to do the same thing. Citrix, though they only have a small percentage of the market, are a highly innovative company. Citrix produce excellent products. Citrix also will explode. I expect this percentage here to also increase, and this is because Citrix have researched this idea of a cloud operating system. Now, Red Hat Linux is a Linux operating system. It's not a cloud operating system. The Citrix have come up with this new technology, which we can call a cloud operating system, and we will look at that next. This is a document with the title Linux and the Cloud Operating System. You can find this document in the Chapter folder in the Documentation folder. Now, imagine you are a company and you discover that you need to have 1,000 servers. If you create 1,000 physical servers, then you will need 1,000 network cables. You will need mini switches. You will need maybe 1,000 power sockets. You will need the space to have those 1,000 servers, and you will need to pay the power bills. Now, imagine you can replace those 1,000 physical servers with one very high quality, high-end server, and then create 1,000 virtual servers to run on that one high-end server. So, you can see how this allows massive increases in efficiency if we are talking in power and we are talking in physical resources if we are talking in the space for all those servers. So, when we say virtualization has solved the issue of server sprawl, enabled massive increases in efficiency and utilization, then we can understand what that statement means. And, more than this, the virtual servers have evolved to become a cloud made of those thousands of virtual services. So, virtualization has become the cloud architecture. However, the basic model of the virtual server, where we're trying to emulate a physical server and application on the separate operating system that runs on what we call a hypervisor. This is a thin layer of code that allows many of these servers to run on one box, and we'll look at hypervisor technology in another module of our course. This module I am trying to emulate, a physical server. If an operating system running on a hypervisor imposes a significant amount of performance and resource overhead and other security issues as well. However, for many use cases, such as scaling the same application across a large cluster, deploying hybrid clouds, or enabling lightweight DevOps, and DevOps are what we call a virtual machine, which is a development environment with an operating system. So we will just unpack the idea of a DevOps. Imagine I would create a server application that runs on a Java server, and then I pass it over to another developer, and he can't run Java on his box. So he installs Java. He installs a run job, and the code will not work for him. If I can give him a virtual machine that has exactly the right job for the application, then it will work as long as he can run that virtual machine on his box, and a virtual machine can have a file size of many gigabytes. So, to pass it over to another developer is problematic. So, if I can create a very lightweight virtual machine with all the resources and give that to my other developer, then that will be a very good thing for me and the other developer, and that very lightweight virtual machine is what I call a DevOps. For many use cases, where I am using things like DevOps or virtual machines in a hybrid cluster, we have a new approach to virtualization emerging, and it's called an operating system virtualization, or containerization, and this lightweight approach is named by its creators as the cloud operating system. It has potential to have a big impact. So, just as we saw with Red Hat Linux moving into the enterprise server marketplace by using a commercially viable Linux kernel to grab a big share of the enterprise server marketplace from the dominant player at the time, Microsoft, so we will see the same thing happen now, where companies like Citrix that are moving ahead with this operating system virtualization approach or containerization or as the cloud operating system. If we go to their website, we can see they have this product called the Cloud Platform. And you can see in their description they say that the Citrix Cloud Platform is application-centric. They are selling their product to business people. Citrix had to have a way of differentiating their product in a way that is user-friendly to the business person that they are talking to when they are trying to sell their product. This idea of operating system virtualization or containerization, they are selling it as application-centric in their system, which they call Cloud Platform. What we will do now is we'll just unpack this idea of operating system virtualization or containerization or cloud operating system. We'll unpack what it means at a lower level of detail now. So, Linux is now capable of cleanly sandboxing processes, that is, processes that are a container with a namespace and a control group. This is what is meant by containerization, creating an application that runs in this container or process. And now, we'll just quickly review what is a Linux process. Now, when we run our application, it runs in what's known as an application thread, and we can have various sorts of policies related to that thread, i.e. security policies. But the basic idea is that inside a process, any two threads can share resources inside that process. Processes out of the box cannot share resources. So, in the Linux architecture, processes are independent. The resources available to one process are not available to another process in general. There are exceptions to the rule, such as the file system. It is possible with groups in Linux to restrict access to files. So, a process can have access to a file that can be denied to another process, but generally we don't place these sorts of restrictions on threads running within a process. Now, it's possible to create a process in a file system or directory that can run as its own independent box or container, and this independent process, we can think of that as our virtual machine, our virtual box, and this can be completely firewalled or sandboxed from other processes because this is inherent in the Linux architecture. And this is the key point for obvious security reasons. However, we have a lot of code running in the Linux kernel and a lot of security issues that flow on from this code. Generally, the more codes you have, the more security issues you will have. So, we can look at this in an architectural sense, in the idea of containerization and processes. And inside a file system, an independent process has been a virtualized box or virtual machine. So here we are looking at it architecturally. Here we have our virtual machine, and at the top layer we have our application. For example, the application could be a Tomcat web server. This is a Java application. So, we will need a Java language runtime, but we can have other languages as well, such as Python or functional languages. So, the application can exist inside the language runtime, which, for Java, would be the Java virtual machine. In this architecture, the language runtime will look to the kernel of the operating system for the resources it needs for the application. These resources could include spawning threads or accessing native libraries such as drivers. An example of a common driver it would look for would be a database driver. In this architecture, generally, the kernel will be a Linux kernel or a Unix kernel. There are two families of Linux we commonly encounter. There is the Debian family, which includes Ubuntu. Then there is the Red Hat Linux family, which includes CentOS. Unix is used as well, such as Oracle Unix or Solaris. Now, when we go below the operating system kernel, it sits on top of a thin layer of code known as the hypervisor. The hypervisor, a thin layer of code in software or firmware to achieve a fine-grained dynamic resource sharing, and this means the other wider resources of the system can be made available to the virtual machine, just as language runtime looks to the operating system kernel for resources inside the virtual machine. The virtual machine looks for wider system resources, and these are made available by the hypervisor. Just as a process will isolate the thread, a hypervisor isolates the virtual machine. So, the hypervisor is the master container, and the virtual machine is a child container. Now, the kernel is a point of vulnerability in our system in a security sense. Now, the virtual machine working with a hypervisor can isolate application running inside of the virtual machine from the wider system. But in the case of a web application, there's always the possibility for the injection of malicious resources, and the kernel operating system is a fertile ground. Once those resources penetrate into the system, they can infest the kernel and multiply, then use it to mount attacks on the system. So, if we are looking at security, security is based on three characteristics: prevention, protection, and detection. There is a patch for the Linux kernel that will ask you to maximize each of these points, and it uses GR security. So, Debian has a patch called GR security, and this script, if you run this script on your Linux box, you will achieve that level of security protection. So, here's the script here. And you can see it's written in the shell language of the box. For every Linux flavor, we have a different shell. So this is Bash shell scripting. This diagram shows a virtual machine running in a cloud on top of a hypervisor in the cloud operating system architecture, or in Citrix language, an application-centric architecture. And you can see the kernel has been removed, and we have an application sitting on a language runtime directly on top of the hypervisor. This is a dramatic simplification of the architecture. In this schema, we are only running one application per virtual machine. The runtime and the application can run in the same address space, simplifying things even more. This offers many advantages for the cloud architecture. This approach is the future trend for the evolution and is making big waves in the cloud sector. The company that developed the Java operating system for the cloud has partnered with two of the largest cloud vendors and innovators. This is the repository for one cloud operating system from a company called Cloudius. It's called OSV, and they are stating it's a new open source operating system for virtual machines and is designed from the ground up to execute a single application on top of a hypervisor, thus eliminating the kernel and giving you superior performance and effortless management when compared with traditional operating systems which were designed for a vast range of physical machines. It has a new API for applications and runs unmodified most Linux applications and can run, most importantly, a standard vanilla JVM. And so you can run all your applications which run in the JVM, such as the Tomcat web server. So, the cloud operating system has been making a lot of waves in the cloud space, mainly because of the performance boost it can give to applications. The website for Cloudius, the makers of the cloud operating system OSV, you can see they have attracted powerful partners Salesforce, and Salesforce is a cloud computing giant, and Google, and there is no need to go into what Google brings to the table. We have this new emerging architecture in the cloud called the Cloud Operating System. Citrix makes one called Zen, and Cloudius make OSV, which works for Java. So this winds up the segment on the Cloud Operating System.